Today we're diving into the high-stakes world of network design, but we're going to have some fun with it. We're going to build a pug-proof network.
So let me just ask you something. Can your network survive a cug? I'm serious. What about, say, a toddler with a pair of scissors? If a single tiny chewed cable can bring your entire operation to a screeching halt, well, you've got a serious problem. But don't worry, we're going to fix it.
Okay, so let's start where a lot of small businesses do, with a network that honestly probably looks a lot like what you have at home. And hey, it works for a while. But as we're about to see, it's a terrible model for a business that actually wants to grow.
I mean, this setup is beautiful in its simplicity, right? You've got your internet connection hitting a router, which goes to a switch, and then all your devices just plug into that. It's absolutely perfect for watching Netflix, but for a business, that very simplicity is actually a ticking time bomb.
So let's imagine our business, we'll call it Network Chuck Coffee, is taking off. We run out of ports on our first switch. What's the quick and easy solution? Well, you just plug another switch into the first one. And when that one fills up, you just add another. This is called daisy chaining, and while it feels like a logical fix, what you're really doing is creating this incredibly fragile chain that's just waiting to snap.
And this is where we meet the main villain of our entire story, the dreaded single point of failure.
And there it is. Disaster. Our friendly little office pug, Moses, decides a network cable looks like a pretty good chew toy. With just one bite, that link is gone. Now, because of our daisy chain design, it's not just one device that goes offline. Oh no, it is every single device downstream from that break. Two whole switches and all the computers connected to them are now completely cut off from the network.
What we just saw was a single point of failure in action. It's any single component, it could be a cable, a switch, a router, that can take down the entire system if it fails. In the world of professional network design, your #1 job is to hunt these things down and eliminate them.
So why does this matter so much more for a business than for your network at home? Well, think about it. At home, downtime means you miss an episode of your favorite show. Annoying, sure. But in a business, downtime is literally measured in dollars and cents. Every single minute that network is down, money is just flying out the window.
So how do we fix this? We stop thinking in these simple, fragile chains, and we start thinking like professionals. It is time to build a tiered architecture.
The difference is really stark. Our daisy chain is this weak, linear thing with a ton of vulnerability. A two-tier design, on the other hand, is centralized and hierarchical. It's designed from the ground up to be less vulnerable and way easier to scale as your company gets bigger.
Let's build one. At the very bottom, we have the access layer. These are the switches that our actual devices, computers, phones, servers, plug directly into. But here's the key. Instead of connecting to each other, they all connect up to a central, much more powerful switch. And that's our distribution layer.
Now, this distribution switch, this thing is the brains of the entire operation. It is way more than just a simple connector. It's a powerful, intelligent hub. It's directing traffic. It's deciding who gets access to what. It's keeping everything secure. You can really think of it as the high-horsepower engine of our network.
But hold on, you might be thinking, haven't we just created a new, bigger single point of failure with that one big switch? And you know what? You're absolutely right, which is why this next step is so crucial. Redundancy. We add a second distribution switch. Now each of our access switches connects to both of them. So if one switch or one cable fails, no big deal. Traffic just flows through the other path. Problem solved. But this kind of reliability comes at a price. This hardware is expensive.
So our coffee company is just exploding. We've expanded from just one office to a whole campus with 4 separate buildings. This is amazing news, but our slick two-tier design, well, it's about to be stretched to its breaking point.
If we just try to connect every building's distribution switch to every other building switch, we end up with this. A tangled, messy, complicated web of connections that's just impossible to scale. It's super inefficient, it's a nightmare to manage, and the switches get overwhelmed. This is definitely not the way.
So, to solve this campus-level problem, we introduce a third layer. We still have our access and distribution layers inside each building, but now we add a core layer on top. This thing is the super-fast, ultra-reliable backbone that connects all of the buildings together. And the difference is just night and day. Look how clean and organized that is. It's incredibly scalable. Each building's distribution layer connects to the central core, and that is it. The core's only job is to move traffic between buildings at insanely high speeds. It's not doing complex filtering or security policies. Its one job is to move data fast.
So what's the relationship between these two professional designs? Well, that two-tier model we started with is often called a collapsed core model. You're essentially taking the functions of that high-speed core and you're collapsing them down into the distribution layer. For a single building, this is perfect, and it's actually the most common professional design you're going to see out in the wild.
And this all brings us to the fundamental trade-off in network design. We've just seen how to build an incredibly resilient, pug-proof network, but that resilience, it doesn't come for free.
Here's the trade-off, laid out plain and simple. The daisy chain is cheap, but its reliability is dangerously low. The two-tier collapsed core model, it costs more, but it gives you high reliability. And that full three-tier campus design gives you the absolute highest level of reliability, but it comes with the biggest price tag.
And, as the saying goes, building a network that can actually withstand failures isn't cheap. It takes careful planning, it takes expensive hardware, and it takes real expertise. And that's exactly why network engineering is such a critical and valuable skill.
So, what are the big things to remember? First, rule number 1, never, ever daisy chain switches in a business. Just don't. Second, always be hunting for those single points of failure and eliminate them with redundancy. Third, pick the right design for the job. 2-tier for single buildings, 3-tier for big campuses. And finally, always remember that every network is a balance between your budget and how reliable you need it to be.
Everything you do online, from your office to your school to the giant data centers that host your favorite websites, it all runs on one of these architectural models. It kind of makes you think, doesn't it? Which one of these designs is holding up your digital life right now?